Pyrek. Yeah, maybe I could have picked a shorter title of my presentation. But anyway, so a little intro about me. I'm Filip, as Eric mentioned. I'm a senior platform engineer in the fintech industry. And I'm also a dev tooling founder of a project called Buttonize.io, which I'm going to talk about in a minute. And I'm mostly focusing on Node.js and TypeScript ecosystem. So that's my area. And we are also organizing serverless meetups in Brno, my hometown, or Prague in Czech Republic. So you are all welcomed to come. So today I'm going to be talking about, I will give you a brief intro into CDK. Then I will tell you our story with Buttonize and how we failed, I would say. And then we are going to go through how to securely connect your customer's account, how to onboard the customers with a ClickOps solution, and how to invoke the different resources in their account in a secure manner. And then there's going to be the last part, how to package all this solution into AWS CDK to provide the best developer experience to your customers. How is all this EDA related, you might ask? Modern cloud architecture is all about EDA, I would say, personally. And all of this needs to be secured somehow. So today we are going to talk about IAM, Identity and Access Management, a lot. And I think it's good to know for everyone how this works and what different things you can do. I want this to give you an idea what different stuff you can do with IAM. And then it's going to be up to you, of course, how you implement it into your startup or project and take advantage of that. Very quickly, infrastructure as a code. Who is using CDK? All right, Terraform. Half and half. We're not going to talk about Sam. Just kidding. So CDK has this concept of apps, which are composed of stacks, which are then going to get transpiled to CloudFormation. I also want to mention that in CDK, you write with your language. So you can use TypeScript, JavaScript, Java, C#, Golang, and Python. It can look like this. So you can create your stack as a class. You can then create new instances of different constructs inside the stack. And this way you can build a whole tree of your infrastructure. You can set different parameters. And since it's a complete language, you can do for loops. You can do like many things during the generation of the template. And you can also secure everything with types, so you are sure that everything clicks into each other. So in 2021, I've been already working for 3 years with serverless in production. And I saw that it's super easy and comfortable to create a Lambda function, put some code into it, do an automation. And but then the problem was how to run it. If you want it to be some one-time job or just some automation which you need to run manually. So I came up with the idea of Buttonize, which was supposed to be like Buttonize your infrastructure. And the idea was that you could create this kind of apps. And let's say we have an e-shop or something like that. And we have our support colleagues, which are doing the customer support. And when the customer complains, they want to generate a discount for them. So it can be super easy for us to implement in Lambda. But then, like deploying your own React app or, I don't know, doing some drag and click solutions, it's not really what we like, developers. So I was thinking it would be super great if I could do something like this, where I create a new instance of the Lambda function in CDK, and below that I can create a new instance of some sort of form or button, and just hit CDK deploy, and it would just magically work. And then you would get this. The idea behind that was that you would sign up at Buttonize as a customer. You would install Buttonize CDK constructs. And then you would prepare your internal apps. Then the customer would deploy their CDK code to CloudFormation, which would then provision all the Buttonize resources with proper access to your AWS account. And then they would use our app online, where they could use the app. You would have the permission system there, and things around that. How we failed, we can say. I've been building Buttonize for 3 years. Not constantly, but with some pauses and iterations. And 99 or 90% of startups fail. So we are no exception here. And I was struggling to build a consistent team, which we would work with. And since the technology, can be quite complex, it was really hard to find the talent, which would be able to work just because they're passionate about it. And also the European VC market is crashing. Apparently, we are at the numbers of new startups like we were 15 years ago in Europe. So that's quite crazy, I would say. And there is overall worldwide slowdown. So if you want to grow when nobody is growing, well, that's going to be tough. And then there are more like philosophical things that maybe internet revolution might be over, that everything that could be on the internet is there. I don't know. We can talk about it later. So to get back to the technology, I have a disclaimer. I'm going to lay out interesting concepts and ideas that I implemented in production for Buttonize. But I want you to make sure that you will check that these solutions are secure enough for you. You should always do that. So secure connections to customers' AWS account. First of all, I would introduce AWS IAM, where two main parts of IAM as a resources are IAM users and IAM roles. Users are the long-lived credentials, which are disencouraged approach, because let's say you will leak your credentials, and let's say somebody doesn't notice for a week. If it's long-lived credentials, after the week they're going to be still valid. But if you're going to use short-term credentials, most probably they will already be expired and you have nothing to worry about. That's one of the aspects. And of course, there's also resource policies, which I'm not going to be talking much about today. I'm going to show more generic approach. And in terms of the roles, they're composed of two main parts. Trust policy, which is saying who can assume the role, who can use the role. It can be an AWS service, it can be AWS account, or it can be user or other role in account. And then there is a permission policy, which is saying what the role can actually do, which we all know well, I would say. The important service in this context is STS, Security Token Service, which takes care, which is not that visible. I guess not that many people know that they're actually using it under the hood, which is taking care of assuming the roles and providing you the short-lived credentials, because since it's short-lived, you need to receive it again. And it works in a way that you have your role credentials or IAM user credentials. You will say which role you want to assume, and if you have permissions to do it, you will get the credentials. Here is the way how you can do it, how you can connect your customers' AWS accounts. You have your user or role. If you're using Lambda, you have some role already in place, and you will allow this Lambda to call STS. And if the role in customer's account is properly configured, which we will take a look at in a minute, then you will be able to properly assume it and then call whatever API call you're supposed to call in their account if you have right permissions to do that. So secure connection to customer's account, how it works. So first of all, in the customer's account, they need to define the trust policy of the role. If I zoom it in, they need to set the principal, which is which is supposed to be your AWS account as a startup. You put it there. And then you want to define external ID condition, which is something like a shared secret, a password. So if somebody hacks your account, they will not be able to to assume the role of your customers because probably they will not hack the database, hopefully. And then there is the second part. That's how you. Oh yeah. That's how you assume it in your code. So you create a STS client in your code. Then you need to put there the role ARN of your customer. And then the important part is source identity and external ID. Source identity has been introduced in 2021, I believe. And its purpose is to make sure that even if you do role chaining, which is you assume a role, then you can assume another role, and that's how it goes. And this way, previously, you could lose track of the identity of the real person behind. This way, you can put there the source identity, and you can, for example, put there the ID of your user in your system, so you know which employee of your customers really did the final action in the AWS account. And you put there, of course, the external ID, which you want to keep encrypted in your database and then retrieve it. There's also this trick. The minimum length, the time of the credentials is 15 minutes. And usually, you might want to minimize this. So there's a way how to do this in IAM. That you can define policy during assuming the role, which will, with which you can cut the permissions even more. So let's say your customers will say you can only do S3 actions, and you can, for example, with the policy, say you can do like list objects or list buckets action with the credentials. Or you can do this. So you will allow everything the role can do, but you will say that the day has to be less than certain value. So this way you can, let's say, do 1 minute. And here is the CloudTrail, how the request then look in CloudTrail. So let's say we are calling list buckets operation, and then we are able to clearly see the source identity value in any request. So customers can securely track what user performed what action in their AWS account. Customers can create their roles by themselves if you write a tutorial, which usually is not the best developer experience, what you want to do. So usually you want some easy one-click solution how to onboard them. For this, there is a great tool in CloudFormation, which is called Quick Create Links. And there is a link to the documentation because, of course, nobody wants to write this. You can copy there. And the thing is that there is the URL of the template, which you store publicly in your S3 bucket, for example. And there is also a stack name, which helps you that your customers really can just click deploy and don't have to fill in anything. And there is the external role ID, which usually you want to generate yourself so that you keep it in memory and customers don't need to fill it in. And this way they open it and it's filled in already. Yeah, so here's the flow. They just load the app. You will generate a link for them. They will hit like add my AWS account. It will open the link. They will deploy the stack. And in this case, it's not 100% perfect that it would be just done, but it can be done. But this way they need to put, for example, the role ARN or just the account ID if you always use the same role name, and yeah, just to confirm that they deployed it. So the template can look like this. You just define the template and put there the access role external ID parameter, which will be then filled in by the query parameter from the URL. You want to set, for example, minimum length, just in case your customers would override it or just customize it somehow. And you want to set there no echo. it's a best practice because this way AWS will know that this one is secret and it should not show it to everyone right off. And then, then we define our role where we will put our account ID, and their external ID will be referenced by the intrinsic functions in CloudFormation. And in the end, we can attach whatever policies we need for our startup to do. It can be reading S3, it can be invoking Lambda functions. Of course, this is very generic, so it's not recommended approach. Ideally, which we will see later, if you use, for example, CDK, you are able to really just use the minimal permissions, so like invoking a particular Lambda function, let's say. So this is how it looks in CloudFormation. Then everything is filled in, and you just need to click on deploy. Here's the QR code. You can get the link there, and use that for your solution. So invoking AWS resources in customers' accounts. That's the third part. And I played with the Grok AI from X here. There's this interesting thing called Bezos API mandate from 2002, where I will read it out. All teams will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through these interfaces. No other communication is allowed other than service interfaces over the network. It doesn't matter what technology they use. All service interfaces must be designed to be externalizable, which is important for us here. And anyone who doesn't do this will be fired. Thank you. Have a nice day. This is important for us because this way you can easily plug into AWS ecosystem, because all APIs they use internally you can use with your startup. It has disadvantage. It has many disadvantages. Like, for example, the reason why AWS console is it can be problematic. It can be loading for 20 seconds the CloudWatch log groups or Lambda functions, is because they're using the same list functions API as you are. So it has its downsides. So let's look at how you can call the resources in your customer's account. So first of all, what we saw before, you just call the assume role command, and you will receive the credentials. And then you can use these credentials when you're creating a new instance of the client. And of course, I don't have it in this slide, but as Anahit was mentioning in her presentation, don't forget to set retries and timeouts. And I tried this interesting concept where, in case of Buttonize, since the customers might be entering like the let's say secret data or like a business data of their customers, I was thinking that maybe they could have a problem with the fact that the data would be going through our infrastructure first when calling AWS. So I decided to do this concept where the front end would call our API. There would be a Lambda, which would assume the role, get the credentials, limit them to, for example, 1 minute, put there where would be the permissions only that it needs, like, for example, invoke this specific Lambda function, so it cannot do anything more. And it would return it back to front end, where it would directly create a new instance of SDK, and it would directly call the AWS account from front end, so no data would go through our infrastructure. Well, there is a way how to secure this even more, because this way, eventually, we at Buttonize could do these calls ourselves. If the customer wants to secure it even more, there was this way that they could put this permission policy into their role, which would deny any access except their Office IP address or VPN IP address, and this way only they could really access it. Of course, we are controlling the front end, so in extreme scenario, we might be able to do that anyway, but this can be a good safeguard. And how to package all this into AWS CDK L3 constructs to really make it a smooth experience. We have a public repository, which is going to stay public even if once we close the shop. And you can definitely inspire from that, because I was pulling some interesting stuff even directly from the CDK code base. And first of all, I would mention how to work with custom resources. Is this feature of CloudFormation, which allows you to extend the capabilities of CloudFormation however you need. It's used widely in CDK actually. The question is also if it's healthy, that amount of usage in CDK, but we don't need to discuss it here. And it works in a way that you will say, I have my resource, which is like my thing, for example, or Buttonize app or page, and you will put there a Lambda handler. You can put there also a SNS topic. And this handler can call your API, which can store data in database or whatever. And then it will say, OK, I'm done. The resource has been created. So this way you can make CloudFormation work even with your startup's resources. The request can look like this. So you have there, most importantly, the response URL, which is like S3 pre-signed URL, where you will do the put call and say whether it was successful or not. And there is also these resource properties. So this way you can configure the resource, put there the parameters, and any input you need. And the response looks like this. You can put there, you can see the data parameter there, which is basically like the attributes of the resource, which you can then reference in your CloudFormation template. And if we look at how we design our Buttonize constructs, you can see that the center of that is the IAM execution role, which is allowing us to do whatever we need in the account. And it's really keeping the minimal permissions. So really like invoke this specific Lambda function, read from this DynamoDB table, etc. And since we don't want to bother our customers with putting their own external ID there, and we want to make sure it's going to be really secure, we created our custom resource, which then generates the external ID and stores it in the template. Because if we did this, if we generated the ID in the template during the generation of the template, it would mean that it would change every time the app would deploy. So that's why we need to create a custom resource, which once it's deployed first time, it's going to stay put. And once we have the role, we have the external ID, we can create Buttonize app, which is like an envelope with metadata saying, here's the app. And then in case of Buttonize, the apps are composed of multiple pages, and then there are the components and everything. Here's an example how to create a custom resource in CDK, which is a custom resource provider. And its responsibility is that even if you create 10 custom resource instances, you will have just one Lambda handler and not 10, because you don't need 10 Lambda handlers. And then you just create a custom resource instance, and you can get whatever attributes out from that you need. With great power comes great responsibility. Implementing custom resources properly is a tough job. By not properly implementing them, you can block your customers' pipelines, for example. That's not really pleasant if this happens in production, and the customer needs to deploy a fix, and it's stuck because of your custom resources. It's recommended, you want to recommend to your customers to rather deploy your custom resources in a separate stack, just in case of the risk management. And also make sure to test all the scenarios that can happen, not just the happy path. When unhandled error comes in, I would recommend maybe respond with success, because again, the last thing you want to do is to block your customers' pipelines. And there are many interesting things, like CloudFormation can call delete without actually first calling create. And similar things can happen. And yeah, think about, for example, how do you handle state when your API is down? So yeah, so here you can get the inspiration You can get the code and use it for your beautiful startup. And I will do a quick recap. AWS IAM is a great and powerful tool, even though it might not seem like it at the first sight. So go and play with it. It can do really fun stuff. Think outside of the box. For example, calling AWS SDK from front end is not really traditional way of thinking about things, but it can be done. CloudFormation, quick create links are fun. Definitely use it either internally or even for your customers. Yeah, with CDK you can deliver a really, really awesome experience, awesome developer experience. Sorry, and be careful with implementing your own custom resources. It can have a big impact if you get your customers. And always do your use case specific security assessment. Since I'm the last presentation, I've been a bit quicker. So if you want to go to Copenhagen EDA, you can use code here. Don't forget to vote for this session in the app. And yeah, that's it. Thanks.